Welcome to all of you. Now we discuss practical number 7, Newton adaptation method for complex root, semester 6, CBCS, B.Sc honors in mathematics. And this is the C programming. Problem 7. Write a C program to find the complex root of the following equation using Newton adaptation method correct to 4 decimal places. Z square minus 2rz plus 2r square equal to 0, where R is the last digit of your CU roll number. Here we use the technique for simultaneous equation. This is the given equation is fz equal to uxy plus ivxy, where z equal to x plus iy, I square equal to minus 1, I is the complex number. If fz equal to 0, the given equation fz equal to 0, then obviously uxy equal to 0 and vxy equal to 0. Now we solve this system of this equation, this nonlinear equation, by Newton adaptation method. Hence, xn plus 1 equal to xn is equal to u into del v del y minus v into del u del y whole divided by del u del x into del v del y minus del v del x into del u del y. That is equal to xn minus bracket u into del u del x plus v into del v del x by whole divided by bracket del u del x square plus del v del x square. Actually convert all partial derivatives in y to x. Here vy means for del v del y and ux means for del u del x. Here we use the Cauchy-Riemann equation where ux equal to vy, that is vy equal to ux put here, and uy equal to vx, so uy equal to minus vx, so put here this plus, so this is plus, and yn plus 1 equal to yn plus u into del v del x minus v into del u del x whole divided by del u del x into del v del y minus del v del x into del u del y, that is equal to yn plus u into del v del x minus v into del u del x whole divided by del u del x square plus del v del x square. And so the given equation, this z square minus 2rz plus 2r square equal to 0, this is the fz. Now we first we separate this real part and imaginary part. This uxy is the real part of this equation, so define the function u. Is the arguments are float x and float y and integer r, and the output is s. This is x square minus y square minus twice rx plus twice r square. Next, the imaginary part of this vxy of the function fz, this is equal to function v is function, the arguments are float jx, float y and integer r, and return is this 2xy minus 2ry. Now we define the partial derivatives of u with respect to x, that is equal to del u del x, we call here ux. The float ux is the arguments here float x, float y and integer r. So this is the u is this with respect to x, derivative partial derivative with respect to x, so x square, the 2x, so this is 2x, and 2rx, so minus 2r, and partial derivative with respect to v with respect to x, that is del v del x, we call here vx. So float vx of arguments float x, float y, integer r. Here v is the function 2xy minus 2ry. So with respect to x, so this is equal to 2y, only 2y. Now this is the main program. This is the float variable x, y, h, k, and error function is the 0.000005 0.5 1, and r is the integer variable enter the R, the last digit of your roll number. This is the percentage D R, of colon print f, the enter the initial approximation of the real root. Cautiously choose the initial approximation because if there is many much error to choose the initial approximation, then this method may fail to exact root, exact solution, exact approximation. Now scan f, percentage f, and ampersand x, and print f, enter the initial approximation of the imaginary part of this, that is y, percentage f y. And float a is the u dilute del x square ux star ux plus del v del x square, that is vx into vx. If a equals to 0, then change the initial approximation and go to up, that is here, go to here, this. Now h is the increment for x is the u into ux plus v into vx by a, and k equal to v into del u del x minus u into del v del x by a. And integer n variable is the step counter n, step counter, and print this n, xn, yn, hn, kn, xn plus 1, yn plus 1. Absolute value of h is greater than equal to error term, or absolute value of k greater than equal to error term, eta or eta, then while this, then we calculate a equal to this ux square plus vx square, and h equal to u into vx plus v into vx by a, and k equal to v into ux minus u into vx by a whole divided by a. Actually, this is the value in this calculation. This is the h is the value ux plus vx whole divided by ux square plus vx square, and k is the value is this u into vx minus v into ux whole divided by ux square plus vx square. And then print n x a y h k x minus h y minus k, and new x equal to old x minus h, and new y equal to old y minus k, and increment of the step n equal to n plus 1, that is n plus plus, and print the required root is this percentage f plus I, percentage f, that is x plus iy and x minus iy, return 0, end this program. Now first we save this program, next compile, and then compile and run, and enter R, the last digit of your roll number, say 9, put here, enter the initial approximation of the real part, say 1, enter the initial approximation of the imaginary part, that is value of y, say 1 also. So this is the output. The required root is 9 plus I 9, 9 minus I 9. So copy this program and output in a Word file. This is the Word file program and the output of this. In a Word file, you must write here date and the right corner top in the top of the page number, date, problem number, description of the problem, and description of the method here. Describe here, all are given in the description box. And now we here Desmos app. Now this practical, the function, this is the function fz. Fz equals to this is the function u. U is the function real part. F equal to u plus iv. So u is the real part of the function. X square minus y square minus 2rx plus 2r square. So this is the real part. X square minus y square minus 2rx plus 2r square equal to 0. And v is the imaginary part of f. This is equal to 2xy minus 2ry, and 2xy minus 2ry equal to 0. So in the Desmos app, we separately put here the real part of this function uxy, and this is the uxy equal to 0, and this is the vxy equal to 0. And here the r, you can give any value of r from 0 to 9, 0 either 0 or 1 or 2 and so on up to 9. If we plot this Desmos app, this is the green curve is this u xy equal to 0. This is the green curve, and this is the red straight line gives this for r equal to 9, r equal to 9. And this is the actually we solve this simultaneous linear equation, simultaneous sorry, non-linear equation. This is the x square y square simultaneous equation, non-linear equation. So intersecting point of these two curve is the point 9 comma 9 intersecting point. This is the green curve and red curve. So actually root is 9 plus 9i, 9i. And another intersecting point is this 9 minus 9, that is 9 minus 9i. So these two nonlinear simultaneous equation uxy equal to 0 and vxy equal to 0, we get this intersecting point of these two curves. We get this the two complex roots. This is the 9 plus 9i, and this is the 9 minus 9i. Actually, and we get here this is the 9 plus 9i and 9 minus 9i. And thank you for watching this video.